generics. The reason we have generics in .NET 2.0 is because Don introduced it as that source patch, and the guys working on the CLR went, huh, that's pretty cool. And so they folded it in as part of the general release in .NET 2.0. But F# took after the syntax of another programming language called OCaml. Anybody here ever heard of it? Yeah, neither had I. Neither has anybody, quite frankly. There's like 4 OCaml programmers in the world, and they all work at the same place. On Wall Street, exactly, because that's such a great place to work right now. The OCaml syntax is unfortunately a bit obscure and a bit twisted. And when they were looking to productize F# and make it into something that real programmers could get use for real work, they decided that some of those syntax elements were going to be a bit difficult to understand and recognize. So they introduced a new syntax that they call light syntax. Now, all of this is basically to say when you write F# code, you're going to type #light, and you're not going to care why, for the most part. It's just going to be there. But because I generally despair of teaching people just do this and don't worry about what's going on, I wanted you at least to know what's happening there. The open command, very similar to C#'s using statement. It says that I want to go reference another namespace. One of the things about F# that they hold as a very firm core value is that you have complete and total access to everything on top of the CLR. So for example, I can write unit tests in F# using NUnit. I can write graphical user interface programs using WinForms. I can write websites using ASP.NET. All of it in F# just by referencing the appropriate assemblies. And to add a new assembly, I just do the classic Visual Studio thing here. So if I want to, add a reference to the Office assemblies, or if I want to add a reference to WPF or any of that kinds of stuff, I just wait for it to go through and find all the assemblies on my box. And there's a fair number of them. I scrolled past it fairly quickly, but you can see that F# also introduces a number of assemblies as well. One of the principal areas that F# is being seen as a big win is in the area of data visualization. If you do any sort of hardcore data crunching and you want to produce graphs and pictures and so forth out of it, F# is great because of that mathematical background that we were just talking about. People who are from a math science background will be able to understand how to program in this very, very easily. As a matter of fact, one of the common things that I've seen done on projects, fortunately that I've not had to do because usually I was able to force somebody more junior than me to do it instead of me, is to take Excel worksheets and transform those formulas into programming code. So someone who's doing some sort of mathematical calculations, doing some sort of schedule planning, those sorts of things, wants to see their system now brought into a website or brought in as part of an overall larger package, you have to take those formulas and turn them into C#. F#, because it's a functional language, is much easier to do that in because Excel is also a functional language. If you think about it, all of those principles of mathematics hold for the Excel language. And so somebody has actually already done that. A gentleman by the name of Luca Bolognese has gone off and taken every single Excel function that the Excel 2007 product offers and created F# versions of it and posted it up on Codeplex, which is Microsoft's open source code site. All right. Oops, come back over here. The // by the way, is an XML comment in the same way that it is in C#. And this is the most important construct in F#, the let declaration. What I'm effectively saying is let this name equal this value. Any questions? Now, a couple of things to notice about this code. First of all, when I say let int1 equals 1, what am I defining? Am I defining a field? Am I defining a method? Am I defining a property? Am I defining a class? What exactly is this? And the answer is twofold. Number one, you don't know. And number two, you don't care. And I mean that, on the one hand, somewhat facetiously. Of course you care. You're a programmer. You want to know how this stuff is going to map to the CLR so that you can make appropriate decisions about things like performance. If I want to call this code from C#, how's it going to look, et cetera, et cetera. And the guys who created F# had to decide how F# syntax would bind to the CLR. So we can look at this inside of something like ILDASM or Reflector, and we can see the decisions that they made. But from a language perspective, functional languages in general worry less about the physical construction of your code, and they worry more about the logical idea that you're trying to express. So here, what we know is that int1 is equal to the value 1. And so now some of those mathematical properties of substitution can kick in, and anywhere we see, later on in this program, anywhere we see the reference to int1, F# could, if it desired, replace it with the value 1. Now, does this mean that int1 is in fact a field? No, it's not. As a matter of fact, if I turn around and build this code, just hit the usual Control-Shift-B or your favorite build instruction, and let's see, where did there's tutorial 2. Okay, we can see a traditional exe comes out of this. If we fire up ILDASM, the IL disassembler, and we look at this thing, how many of you have looked at ILDASM before, by the way? Or used Reflector or something like that? Okay, this is showing you the actual compiled structure of what's inside a .NET program. So if we open up tutorial, first of all, where did this tutorial? This is a class in ILDASM. So one of the things that F# has done is it's taken this entire file and turned it into a single class. We go back to ILDASM and we look for something that's referenced as int1, and there we see get int1, which turns out to be, by looking at this, a property. Get underscore int1 is what C# properties and VB properties turn into. Get underscore property and set underscore property. So this is still physically mapping to something that we can recognize from regular CLR code. So it's not just a field. But within the code itself, do I really care what int1 is? And the answer is no, nor should you. You just want to know that int1 holds an integer value, and that's it. We're done. Okay? Make sense so far? This notion, by the way, of doing this name to value binding is a core concept in any functional language, including F#. All right? So this is why the let construct is probably the most important construct that you'll learn in F#, because you're going to be doing it all the time. And we're going to use this not only for additional value bindings, like we see here, but a little bit further down, this is how we define a new function. I say let name equals value, where the value in this case is actually a function that takes int1 and adds int2. Now in of itself, this is not a very interesting function. It doesn't do much. So let's create a new function that does something a little bit more mathematical. And by the way, I have to apologize in advance. If you start playing around in this space, if you start looking at functional languages, whether it's F# here, or whether it's Scala over on the Java virtual machine, or whether it's Haskell or Erlang, you will get reintroduced to all that mathematics crap that you tried to forget once you graduated from school. Okay? Because the functional languages have this history of being very closely aligned with the math and science community, a lot of the examples will be from upper mathematics space. So they'll be computing polynomials. They'll be introducing, the traditional quadratic equation, right? Plus minus 4ab square root, whatever, I forget. It's been a long time since I was in school. My kid actually is doing that stuff, and it's like, oh man, now I know how my dad felt when I was, going through school and asking him for help on my homework and thought he was an idiot because he couldn't remember how to do this stuff. Be kind to your parents. So here we see f of x. Now again, notice that the way we describe this, right, f is a function taking this value x. By the way, how do we know that it's an integer? You can see IntelliSense is kicked in here, right? It says that it's an int. How does it know? As a matter of fact, if we go back and look at int1 here, It knows that it's an int. How? It's a feature very common in functional languages known as type inference. How many people have started